Hello guys, in this video tutorial we are going to do an analysis of BNF, EBNF and syntax graphs. Before that, we'll see what are context-free grammars and what is a meta-language. Okay, let's look at this example. You can think of any verbal language. Here I have used English and Sinhala languages as the examples. According to this, when we are writing a simple sentence in English, we have to write the subject, verb and the object respectively. Whereas when we are writing it in Sinhala, we have to write subject, object and verb respectively. As you can see here, if we change the format of the sentence is grammatically wrong. Programming languages are also like this. We should create correct grammar to create any programming language. Here the correct means that grammar has to be complete and unambiguous. In programming languages, this grammar is used to create the compiler of a programming language. Now we will see what are context-free grammars. Context-free grammars are language generators which describe the syntax of natural languages. As you can see here, there are two types of symbols to describe that syntax. First one is terminal symbols. Terminals are things that can't be divided any further. You can see the examples here. Keyboard symbols like semicolon, plus sign, equal sign, curly brackets and the star mark. Integers and characters. Loops names like if, while and do. Data types like integer, double and float. Other type of symbols are called non-terminal symbols. Non-terminals are the things that can break down or explain. You can see the examples here. List of numbers, sentences, words, expressions, terms, statements and the programs. Basically, there are two types of context-free grammars. First one is Backus-No form. Short term is BNF. And the other one is Van Wijngaarden form. Here we consider about BNF only. BNF is one of the meta-languages. A language which is used to model programming languages is known as a meta-language. A grammar is a finite non-empty set of rules. Now we'll see here how to write rules in BNF. As you can see here, a rule has a left-hand side and a right-hand side, and it consists of terminal and non-terminal symbols. Left-hand side always represents one non-terminal and right-hand side can represent any number of terminals and non-terminals. And also, non-terminal symbol can have more than one right-hand side. As you can see here, we can separate the left hand side and right hand side by using an arrow or two semicolons and equal sign. Now we'll see how to write BNF grammar by using some examples. Here we have taken if loop as the example. We can use if loop in several ways. Here is the first structure of the if loop that consists of only the if part. Okay, now we'll write the BNF of that if loop. As you can see here, on the left hand side we write if loop as a non-terminal because we can explain it. And right hand side consists of the if part. Here we have explained the if loop using if part. If part also we can explain. So, as the second rule, on the left hand side we write if part as the non-terminal. Then we can describe that on the right hand side. So, on the right hand side we write if as a terminal, and then the condition as a non-terminal, and then open curly brackets as a terminal, and then the body as a non-terminal, and at last close curly brackets as a terminal. Now we wrote the BNF grammar of the if loop using two rules. You can see here how to write that using only one rule. Okay, now we will move on to the second structure of the if loop. It consists of if part and the else part. So we can write BNF grammar for that if part and the else part separately. Or we can write that as only one rule. Now we'll see how to work with recursion in BNF. Recursion means calling itself again and again. To show that, I have taken a simple example. This example is having begin and end parts and 4 statements. First we write begin, Then the four statements. First statement is A equals B plus C. Second statement is B equals A plus D. Third statement is X equals X plus 1. Last statement is D equals E plus F. At last we write the end part. As you can see here, this whole code we can consider as a program. And the four statements we can consider as the body of this program. Then we can write BNF grammar for this program. So, on the left hand side of the rule, we write program as a non-terminal, and then we can explain that program using begin, body and end parts on the right hand side. Here the begin and end parts are terminals, so we write those without angle brackets. Next we can explain the body part as a statement or statement followed by the body. Recursion will occur here. Focus on this and I'll explain it in simple manner. In the first case, A equals B plus C statement followed by the other three statements. So other three statements we consider as the body. So in the first case, a statement is followed by a body. As you can see here, there is a body part at the left hand side and also the right hand side. That means right hand side body part is calling itself again. Then in the second case, B equals A plus D statement followed by the last two statements. That last two statements consider as the body part here. So the body part is calling itself again. Then in the third case, X equals X plus 1 statement is followed by the last statement. Here the last statement is considered as the body part. So the body part is calling itself again. Then in the fourth case, we only having D equals E plus F or the last statement. There's no body part under that. So in this case, body part is only the statement. That is the terminating part of the loop or the recursion. If there is no terminating part on the right hand side of the rule, that grammar is ambiguous. But here we can say that this grammar is complete and unambiguous. Now we'll move on to the third structure of the if loop. That consists of if part, else if part and the else part. Now already you know how to write if part and the else part in BNF grammar. We can describe if loop using if part, else if part and the else part by writing on the right hand side of the rule. And then we explain if part in BNF. That is already you know. And next, the else if part. It is possible to have multiple else-if parts in the if loop. Therefore, we describe else-if parts as else-if part followed by the else-if parts, like previous recursion example. Here the terminating part is else-if part. And at last we describe else part as usual. Here we are going to analyze the extended Becker-Snow form. Short term is EBNF. This is also same as the BNF. Actually, this is the extended version of the BNF. EBNF is having some operators, or it is using some extra notations to create grammar. Because of that, we can say EBNF is a collection of extensions to BNF. Now we'll see what are the notations in EBNF. First one is optional. EBNF allows optional terms in the grammar rules through the use of square brackets. You can see the example here. We have taken the same example that we used in BNF. As you can see here, we can write BNF grammar for the if condition. That is already you know. Now we'll see how to write that in EBNF. On the left hand side, we write if condition as a non-terminal. And then on the right hand side, first we write if part. Else part is optional. That means if loop can exist with else part or without else part. Second notation of the EBNF is repetition. Curly braces indicate that the enclosed pattern can be repeated indefinitely or simple left out. If we use that curly brackets with the plus sign, it means one or more times. And if we use that curly brackets alone or with the star mark, it means 0 or more times. You can see the example here. We can describe an expression as term followed by operator followed by an expression or a term in BNF. That means there is a recursion. We can describe the operator as minus or the plus sign. We'll see how to write this grammar in EBNF. On the left hand side, we write the expression as a non-terminal. On the right hand side, inside the curly bracket, we write term followed by plus or minus operator followed by the expression. Because of the plus sign, it indicates the pattern which is inside the curly brackets can be repeated one or more times. And the other way, we can say that expression is only a term. Through this example, you can understand there is no recursion part in EBNF. Third notation of the EBNF is grouping. In the previous example also, you saw that. Here we use round brackets to group several terms combined with O symbol. We write O symbol as short straight line. In this example, you can get a good idea about grouping in EBNF. I think it is no need to explain that. You can just understand by looking at this example. If you remember, in BNF, we wrote three structures of the if loop and created the grammar for that. Here I am going to create the grammar for three if loop structures using only one rule in EBNF. Now already you know what are the three structures of the if loop. First structure is having only the if part. Second structure is having if part and the else part. Third part is having if part, else if part and the else part. Now we will write the EBNF grammar for those if loop structures. On the left hand side, we write if loop as a non-terminal. Then we write if part on the right hand side. Now you know else if part and else parts are optional because if loop can exist only with the if part. So here we write else if part and the else part inside the square bracket. And also it is possible to have multiple else if parts in the if loop. Therefore, we write that inside the curly brackets also. That indicates else if part can be repeated 0 or more times. Now we will move on to the syntax graph. This is very simple and you can understand that easily by using this video tutorial. Actually, by using syntax graphs, we can describe BNF and EBNF rules graphically. Now we will see what are the symbols in syntax graphs. We use rounded symbol to display the terminals. Now you know the examples and you can see how to write those examples inside the symbol. We use square symbol to display the non-terminals. Here you can see how we write them inside the square symbol. And then we use line with an arrowhead to show the flow of the syntax graph. Terminals and non-terminals are connected through this flow symbol. There are three basic concepts in syntax graphs. That means we can write any type of a grammar rule using these three ways. First one is sequence. In the example you can see start of the syntax graph, then the non-terminal A, then the non-terminal B, then the non-terminal C, and then the end of the syntax graph. This type of syntax graph flow as a sequence. Second one is alternation. Here you have to select the path. In this example you can see there are three paths in the syntax graph. According to your problem you can select one of the paths. Third one is iteration or the recursion. As you can see, in that case we have to go back and repeat the syntax graph again. Now we'll see how to write syntax graphs using some examples. You can see the BNF grammar rule here. It has recursion because both left hand and the right hand sides are having same non-terminals. First we'll create syntax graphs for the statements that is having only one statement. As you can see here, we can simply write that as a sequence. We write left hand side of the rule at the start of the syntax graph. We write left hand side of the rule at the start of the syntax graph. Statement is the non-terminal and semicolon is the terminal. Next we'll create syntax graph for the recursive problem. As you can see here, we have to use repetition concept here. In this diagram, clearly you can see what are the two parts of the syntax graph. brown color line indicates the sequence path and the rose color line indicates the recursive path. Okay, we'll move on to the second example. This example shows the alternation in syntax graphs. First, we can create a syntax graph for the term plus term by using sequence concept. Terms are non-terminals and the plus operator is a terminal. Then we can create a syntax graph for the term minus term by using sequence concept. In this syntax graph, you can see how to combine those two syntax graphs by using alternation concept. And also, you can see the two paths more clearly. Now we'll see how to write syntax graph for the if loop. As same as in EBNF, we can design only one syntax graph for all if loop structures. Here you can see the syntax graph of the first if loop structure that consists of if part only. And then here you can see the if loop with if part and the else part. Then here you can see the third if loop structure that consists of if part, else if part and the else part. Here, repetition concept occurs because if loop can have multiple else if parts. Now you can see we can graphically design the three if loop structures inside one syntax graph. Now our analysis is over. At the end, now you have some basic idea about BNF, EBNF and syntax graphs. And also you know how to use them. At last, based on the reviews of this tutorial, we can move on to some conclusions. BNF is a meta language that gives a formula for constructing legal strings. Extended BNF, that means EBNF, improves the readability and the consistency of BNF through the extensions. And also it is more descriptive than the BNF. And we can use syntax graphs to visual modeling of the grammar rules of the BNF and EBNF. Thank you for watching this video. We hope you liked this video and you would have learned something from this video. Please leave your valuable comments on this video and also you can share and like this.